In this video, I'm going to show you how to use the null factor law to solve a more complex quadratic equation. The null factor law, to remind you, says that if you have a product and it's equal to 0, then one of those factors must be 0. Here is a quadratic equation. This quadratic is written in standard form, x squared term, x term, constant term equal to 0. But if I'm going to solve this equation using the null factor law, then I must be able to write this as a product of two factors. In other words, I have to factorise this quadratic. If I'm going to factorise that quadratic, I need two numbers that multiply to give me negative 36, careful of the sign, and add to give me 5. What two factors of 36 add to give me 5? Remembering it's negative, so I'm actually looking for the difference between the two factors to be 5. If you get stuck, do the factorisation. 1 times 36 doesn't differ by 5. 2 times 18, 3 times 12 differs by 9, need 5. 4 times 9, they differ by 5. So my numbers are going to be 4 and 9, and I need one of them to be negative and the result to be positive. So the bigger number has to be positive, and the 4 in this case has to be negative. Now, you might know that I can then just write this as x minus 4, x plus 9, but I'm going to show the extra line or two just to make it clear. In particular, because when we get to non-monic quadratics, I have to show that extra few lines. So let's put that in. X squared, split the 5x into negative 4x plus 9x. Negative 4x plus 9x minus 36 equals 0. Now you can just write minus 4x, that's fine. I just wanted to make that very clear. Okay, factorise the left two, then the right two. The left two have a common factor of x minus 4. The right two have a common factor of 9, leaving x minus 4. And I got the same common factor, which is what I expected, x plus 9, x minus 4 equals 0. And you see, these numbers end up directly in here for a monic quadratic, not if it's non-monic. Okay, now I can solve this equation, because the null factor law says if the product is 0, then either this factor must be 0 or that one must be 0. So let's write that. X plus 9 equals 0, or x minus 4 equals 0. Well, if x plus 9 is 0, then x is negative 9. If x minus 4 is 0, then x is positive 4. And there are my two solutions to this quadratic equation. Now, be very careful. Notice how the numbers for the factorisation were negative 4 and positive 9. The factorisation was negative 4, positive 9. But the solution was positive 4, negative 9. Factorise negative 4, solution was positive 4. Factorise positive 9, solution was negative 9. Be very careful. It's a very common mistake to get those signs wrong. Let me show you a couple more. X squared plus 7x plus 12 equals 0. To solve this, I need to factorise so I can get two factors whose product is 0. To factorise this, I need two numbers that multiply to give me 12 and add to give me 7. What two numbers multiply to 12 and add to 7? It's going to be 3 and 4. So again, I'm going to write the extra two lines to make it clear, but if you're comfortable, you can go straight to that line. X squared plus 3x plus 4x plus 12 is 0. Factorise the left two, x plus 3, and the right two, 4x plus 3. Common factor, x plus 4, x plus 3 equals 0. Again, if you're comfortable going straight from the factorising numbers being 3 and 4 to the result being x plus 4, x plus 3, x plus 3, x plus 4, doesn't matter which order you write them in. If you're comfortable with that, then you can go straight here. You don't have to write these two lines. I'm just doing it for consistency with non-monics, which is next. Okay, if you can do this, now I can solve this because I've got a product equal to 0. Therefore, x plus 4 must be 0, or x plus 3 is 0. And if x plus 4 is 0, then x is negative 4. Started writing the wrong thing. Negative 4. And if x plus 3 is 0, then x is negative 3. So the solution to this equation is x is negative 4 or x is negative 3. Like all quadratics, there are two solutions. Again, be careful. Positive 3 was the factorisation, negative 3 was the solution. Positive 4 for the factorisation leads to negative 4 as the solution. Be careful. Let me show you another one to show you the value of learning the patterns. Here is x squared minus 6x plus 9 equals 0. Now, if you recognise the pattern, you can get straight to the next line. X squared minus 2 times 3x plus 3. It's a perfect square. But if you don't recognise it, what two numbers multiply to 9 and add to negative 6? Well, that's got to be negative 3 and negative 3. They're the same. So this is a perfect square. It's x minus 3 squared equals 0. If you like, maybe I should show you all the lines just to convince you in case you don't know that pattern. X squared minus 3x minus 3x plus 9. And you write out every line just to convince you. Factorise the left two, x minus 3. Now carefully, factorise the next two, take out the negative sign, minus 3. Then flip the signs of what's left. And you will get two factors that are the same. X minus 3 times x minus 3 is 0. This is x minus 3 squared equals 0. But again, just to show you explicitly, if you recognise the pattern, it's quicker. X squared minus 6x plus 9 is x squared minus 2 times 3 times x plus 3 squared, which means it's x minus 3 squared. If you know the pattern, you can get there quicker. Okay, I've got a product here. Either way you write it, I've got a product. But the factors are the same. So there's actually only one solution. Therefore, x minus 3 equals 0. So you could write x minus 3 equals 0 or x minus 3 equals 0, but you're saying the same thing. They're exactly the same factor. So what we actually say is there's two solutions, but they're the same. It's really only one solution. If x minus 3 is 0, then x is 3. That's the only solution to this equation.